Hello everyone. In this video we will be overviewing how we took a data mining approach to heart disease in the United States and how we can solve this issue around the world. So who are we? My name is Sam, my project partner is Kadir, and we are both computer science majors at the magnificent George Mason University. This presentation is going to be for our data mining class term project. So as you can guess from the title page, we are focusing on heart disease. So what is heart disease? It's a blanket statement that basically refers to anything that is a condition of the heart, and it's interchangeable with cardiovascular disease. We're going to be focusing on coronary heart disease, which is basically a narrowing or blockage of the blood vessels, typically leads to heart attack and chest pain. So now, why would we take on this sort of task? Well, let's look at some of the numbers. The CDC reports that the top causes for death include heart disease, cancer, respiratory disease, and stroke. Heart disease takes the cake at number 1. It accounts for over 600,000 deaths in 2016, and cancer is at about 600,000 as well. Now, what does this say about our health? Are we making poor decisions in what we're eating? Are we not exercising? Are we not sleeping? Are we too stressed? Well, in any case, prevention is the best solution. So with that in mind, how do we then prevent CHD with a data mining approach? Well, first things first, we need a lot of data. So we're looking at the Framingham Heart Study. This was an ongoing study from 1948 in Framingham, Massachusetts. It dealt with over 5,000 participants, and it predicted over 10 years, 20 years, and 30 years whether they would have heart disease or not. Now, from this study, a lot of other studies have occurred as well, especially dealing with genetic analysis. But to continue on what we're talking about, what happens when you get diagnosed with heart disease? You go through plenty of tests. You go to the hospital, you get blood tests, you get weight. They take ECG tests, tons and tons of tests just to predict if you're going to have heart disease, and it's usually after the fact. Now, who wants to go through all these tests? So what we're going to do is take a data mining approach. So what we're going to do is input our data, and we're going to look at a few analytical things. We're going to take a look at some of the statistics from this Framingham data set. So over the 5,000 patients, about 3,500 developed heart disease and 600 did not. There's about 2,400 females and 1,800 male participants. Now, any of the patients that had any sort of incomplete data, now, as I was saying, with the execution of the classifiers that we decided to use the k-nearest neighbors and the artificial neural networks. So the first step was with pre-processing was to remove any missing info. So any patients that did not have complete information, we removed them from the study, from our study, just because it didn't actually impact our accuracy scores, and it wasn't too many of the patients. It was roughly around 300 to 400 patients out of the 5,000 that we had. Then we also looked at redundant or irrelevant features. So things like, for instance, education, which actually has nothing to do with the outcome of your medical condition. We also removed things like whether they're a smoker or not, because there's another feature that asks how many cigarettes a day they smoke, which actually answers both of those questions, right? And from one of the papers that we read called Prediction of Coronary Heart Disease Using Risk Factor Categories by P.W. Wilson, he mentions that the diastolic blood pressure is technically redundant because systolic blood pressure is commonly used to predict any heart complications, so we removed diastolic blood pressure as well manually. Now, when testing our classifiers, specifically the k-nearest neighbor classifier, we tried different variations of k. We started from 1, went to 50, and we compared the accuracy results. And as you can see from the graph, you can notice that as k got larger from 30 to 35, it dropped off significantly, so we stuck with k at 17. Now to talk about our results, the k-nearest neighbor achieved about 86.7% accuracy, while the neural network achieved 85% accuracy. So from here, my partner Kadir will take you on to the next.
As we have noticed, Cannon and neural net model provided very promising results. However, we've decided not to stop here, and we wanted to improve our accuracy. The next model that we've explored is logistic regression. We've used sklearn's logistic regression classifier to train and test on our datasets. Before we start, we've done some pre-processing steps where we first wanted to do feature selections to remove attributes that have no significance in predicting a class label, which is 10-year CHD. In order to do that, we've used the pairwise correlation value using Pearson's coefficient to extract and use only features that has a strong correlation with our class label. After running our pre-processing steps, we are able to narrow down the feature size to just 7 features, and after running the model using k-fold validations, we are able to get an accuracy of 88.2%. Lastly, we've tried a decision tree classifier because we wanted to see what we would get since the time complexity of a decision tree is faster than other algorithms we used. So we built a model using decision tree classifier, and we trained and tested the model using different level of depths, and what we found is the depth increases, the accuracy of the tree increases as well, which is obvious. However, the model that we built doesn't really generalize well. So to avoid overfitting the data, we implemented a pre-pruning rules that basically stops the tree from growing. But since we don't want to miss important trends in the data, we've decided to implement a tree using random forest algorithms. Um, with that, we are able to get an accuracy of 85%, which is comparable to other classifiers we've tested. In conclusion, in this project, we've utilized different data mining techniques and algorithms to build a model that's able to predict risk factor of heart disease, and we are able to get a maximum accuracy of 88.2% using logistic regression.